Okay, good afternoon to everybody. Today we'll start a new chapter, the straight line in three-dimensional geometry, coordinate geometry. And this is the last chapter for us. First of all, we have to define what is a parametric equation and symmetric form of a three-dimensional straight line. And we will define in this lecture what is the shortest distance between two lines. Then we'll try to find the distance of the point this from the plane this and measure parallel to this line. This is actually standard form of three-dimensional straight line. So we'll try to solve this problem today. Okay, first of all, we'll discuss some basic concepts of the straight line in three-dimensional geometry. In our previous lectures, we have first of all we have finished the first chapter, rectangular coordinates in three-dimensional geometry. Then we finished a chapter, the plane in three-dimensional geometry, and in this chapter we are studying about straight line in three-dimensional geometry, coordinate geometry. Okay, now what is the parametric equation? Parametric equation. Parametric equation. Suppose any straight line. This is the straight line, and this is the straight line. Suppose any point P will be x1, y1, and z1. Okay, so and this is the any point P, x, y, z. So for this kind of points, if LMN, if L, M, N are directional cosines, okay, directional cosines, and let P be any point, and this is the P1 point, P1 be any point x1, y1, and z1. Okay, any point on a line L. So the distance, so then locus L can be defined as, can be written as like this: x minus x1 equals to cos alpha, y minus y1 equal to cos beta, and z minus z1 equals to what will be cos gamma. And this is can be defined as RL, and this is RM, and this is Rn, because proportional to the directional cosines. So therefore x can be written as x equals to x1 plus RL, y equals to what will be y1 plus Rm, and z equals to what will be z1 plus Rn. Okay, suppose this is an equation number 1, where the parameter r represents the variable length p1p. Okay, this is the variable length p1p r. Okay, r represents variable length because for distance between x and x1 will be depending on r. So this will be the variable length. And this, if A, B, C be the direction ratios, if A, B, C the direction ratios, okay, direction ratios, then the L locus of this equation can be written as x equals to x1 plus at, y equals to y1 plus bt, and z equals to z1 plus ct, where ABC has the what directional ratios, and t does not depends on the distance of the variable length p1p. Okay, so t does not. So this is the another form of equation in three-dimensional geometry. Okay, we can represent in terms of direction directional cosines and directional ratios. This 1 and 2 is the actually parametric equation. Okay. Now symmetrical form of three-dimensional straight line. Suppose from equation 1 we can write, from equation 1 we can write what, like this: x minus x1 divided by L, y minus y1 divided by M, and z minus z1 divided by what will be n. This equals to R. Okay, can we write? Okay, from this we can write what? X minus x1 divided by A, y minus y1 divided by B, and z minus z1 divided by what? C. This equals to what? T. So this is equation number 1. This is equation number 2. Okay. Equation 1 is the symmetrical form of what? 2. These two, because these two can be found from equation 2. So this is the equation of straight line, standard form of symmetrical form of the straight line in three-dimensional geometry, coordinate geometry. But first one is the actually symmetrical form of equation 2. We have to remember this one. Okay, first example. Find the example 1. Find the distance of the point. Distance of the point 1 minus 2, 3. From the plane, x minus y plus z equals to 5. Measure z parallel to the line. The line x by 2 equals to y by 3 equals to z divided by minus 6. Actually, you have to find, we are given two equations. One is plane, and this is the equation of plane, and this is the equation of what? Straight line. And we have to find the distance from this point to the plane of this line. Okay, we have to find on this. So we are given,
so লিখাটা একটু ব্লার্ড দেখা
so we are given, actually there are two equations. One is plane, x minus y plus z equals to 5, equation number 1, and another is the equation of the straight line in three-dimensional. This is equation number 2. Therefore, the equation
sir there is x by 2 sir, not x by 6.
z by minus 6.
Sir x by 2 sir.
X by 2, right. X by 2. The equation of the line through the point through the point 1, -2, 3, and parallel to 2. Parallel to equation straight line 2 will be what? X minus 1 divided by 2, y plus 2 divided by 3 equals to z minus 3 divided by minus 6. This equals to R, say. Okay. Actually, this one from what? This point, x minus 1, y minus 2, that means y plus 2, and z minus 3 divided by minus 6. And this ratio equals to what? R. So this is equation number 3. Okay. Therefore, x minus 1 divided by equals to R implies what will be? Twice R plus 1. Twice R plus 1. Similarly, y equals to what will be? 3R minus 2, and z equals to 3R plus 6. So from the first ratio, x minus 1 by 2 equals to R. Therefore, x equals to what? Twice R plus 1. Similarly, y equals to what will be? Thrice R minus 2, and z equals to what will be? Minus 6R plus 3. So putting the values of x, y, z, putting the values of x, y, z in equation 1, in the plane 1. Okay, in equation 1 we get what? X equals to twice R plus 1 minus thrice R minus 2 plus z equals to minus 6R plus 3. This equals to what? 5. So from this we can write what? Twice R minus thrice R minus 6R. What will be? Minus 7R. Okay. Plus 1 plus 2 plus 3 and minus 3. So plus 3 plus 3 plus 6. So this equals to what? 5 minus 6. Therefore, R equals to what will be? R equals to 1 by 7, right? 1 by 7. Therefore, the point of intersection of the plane, therefore, the point of intersection of plane will be what? X, comma, y, comma, z. That means what? Just x equals to what? Twice R plus 1. That means 2 by 7. 2 into 1 by 7 plus 1. That means what? 2 by 7 plus 1. Then y value what will be? 3 by 7 minus 2. And another point, minus 6 by 7. Minus 6 by 7 plus 3. Okay. This is the coordinate. Therefore, the required distance, the distance equals to what will be? From the given point, this is the given point, 1, minus 2, 3. So this 2 by 7 plus 1 minus 1 whole square plus second one, 3 by 7 minus 2 minus 2. That means plus 2 whole square plus last what will be? Minus 6 by 7 plus 3 minus 3 whole square. So after simplifying this, actually you get the distance is 1. Okay, because 1 will be what? Cancelled. 2 by 7 means what? 4 by 49. and 3 by 4, 9 by 49, and will be 36 by 49. Okay, 3 will be cancelled. So we get 49 divided by 49. That means we get only 1. This is the required distance. Okay, so the equation, actually the given plane is this, and we are given point is 1 minus 2 3. So you have to find the distance from this point to the plane. So, and this is the symmetric form of the straight line at this point, from this point. So from this ratio we get x, y, z. This is the point actually on plane. Okay, so after putting these values in on the plane, then we get the value of r. So putting the value of r, we get the coordinate of x, y, z on plane. So this point is this point, 3-dimensional point. So just distance between this first one minus first one, that means abscissa minus abscissa, ordinate minus ordinate, z values minus z values. Okay, so this is the distance, is unit distance. Okay, now another example, second example, we have to find the perpendicular distance of the point 7 6 7 from the 3-dimensional line. This x minus 2 divided by 2, y minus 1 divided by 3, and z minus 3 divided by 6. So this means this is the given point P, and we have to find out the perpendicular distance. This means we have to find out the PM. Okay, so we are given actually what given line. Given line is what, x minus 2 divided by 2, y minus 1 divided by 3, and z minus 3 divided by 6. This is equation number 1. Therefore, the direction ratios of the straight line 1 is what will be 2 3 6, this value. Okay, 2 3 6. Okay, and another, and a point A, any point 2 1 3. This is the x1 y1 z1. Okay, x minus x1, y minus y1, z minus z minus. This is the symmetrical form. So we can find a point 2 1 3. This is the 2 1 3. Okay, 2 1 3, x1 y1 z1. So this is the x1 is a point on line 1, okay. Now if L, M, and B direction cosines of 1, then L by A means what? L by A, M by B, and N by C. Here ABC equals to what? 2 3 6. Remember it. So this means what? We can write L by what? 2, and M by 3, and N by 6. Okay, so from this line actually we can write L by 2 equals to M by 3 equals to N by 6 equals to what will be root over L square plus M square plus N square divided by root over 2 square plus 3 square plus 6 square. This equals to 1. L square plus M square plus N square. In directional ratios and direction cosines that be rectangular coordinates, we have proved this result: L square plus M square plus N square. Directional cosines, sum of squares of all 3 directional cosines is what? 1. So we get actually this result means what? 49. Okay, 49 means what? 1. That means we get 1 by 7 result. So therefore L equals to what will be? L equals to 2 by 7. M equals to what will be? 3 by 7, and N equals to what will be? 6 by 7 we get. Therefore now M, this is the projection. M equals to the projection of AP the projection, remember it, projection of AP on line M. Okay, so this means what? Actually, L into projection will be what? X1 minus x2 plus M into y1 minus y2 plus N into what will be Z minus Z1. This is the formula of projection. Remember it. Formula of projection of AP on line M. That means the value of projection will be, we have to use this formula. So L means what? L equals to 2 by 7. X1 means what? X1 means what? 7. Okay, 7. And X2 means what? 2. Okay, this is X1 y1 z1 and this is X2 y2 z2. Just using this 3 by 7 M, 3 by 7, and y1 minus what? 6 minus 1 plus 6 by 7, 7 minus 3. So we get actually this result what will be 10 by 7, 10 plus 15 plus 24 by 7. That means 49 by 7 equals to what? Only 7. Therefore, AM equals to what? AM equals to 7 we get. And AM square equals to what will be? 7 square. So AP square equal to what will be? AP square. Again, distance between AP after this line. Again, AP equals to what will be? Again, AP square what will be? Distance between 2 points. 7 minus 2 whole square plus 6 minus 1 whole square plus 7 minus 3 whole square and square root by using the distance formula in 3-dimensional geometry. Remember it. So this equals to what will be? AP square equals to 7 minus 2 means what? 5 square and 5 square, and this is also 4 square. That means we get 66. Therefore, AP square equals to what? AP square equals to 66. So from the figure, perpendicular distance MP. Okay, perpendicular distance will be what? MP. What will be? By Pythagoras theorem, AP square minus what will be? AM square. AP square means 66 minus what will be? 49. AM square equals to what was? 49. Therefore, we get only 17. Therefore, and this will be Pythagoras theorem, by Pythagoras theorem. MP equals to what will be? Root over 17. This is the result, perpendicular distance, required perpendicular distance. Example 3, the distance, find the distance of the point of the point minus 1, minus 5, minus 10 from the point of intersection of the line x minus 2 divided by 2, y plus 1 divided by 4, z minus 2 divided by 12, and the plane x minus y plus z equals to 5. Actually, we are given this three-dimensional straight line. This is the given straight line. Let this straight line parametric form for z minus 2 divided by 12 equals to r. Say. So this is the equation number 1. So from this point, by the ratio x minus 2 divided by 2 equals to what will be r. So this implies x equals to what? Twice r plus 1, 2, and y equals to what will be? 4r minus 1, and z equals to 12r plus 2. So therefore, now putting the values of x, y, z in given plane. In given plane is what? Actually x minus y plus z equals to 5. X minus y so just putting these values, we get what? Or x equals to twice r plus 2 minus 4r plus 1 plus 12r plus 2 equals to 5. So from this, we get actually 2r, 12 or 14r, 14r and 10r. 10r equals to 2 and 2, 4, 5. That means 5 minus 5. 5 minus 5 means what? 0. Therefore, r equals to what actually? We get 0. Therefore, the intersection point is the intersection point is what? Actually, just putting the value of r in x, y, z, we get 2 comma minus 1 comma 2. Okay, and this is the equation of plane x minus y plus z equals to 5, and this is the intersection point. Okay, intersection point what? 2 minus 1 2, and this is the minus 1 minus 5 minus 10 point. Okay, this is the P point and this is the M point, and this is the equation of plane. Therefore, the required distance, required distance, what will be? Distance PM. PM what will be? 2 minus 2 plus 1 whole square, or minus 1 minus 2 whole square, plus minus 5 plus 1 whole square, plus minus 10 minus 2 whole square. This is the required distance. So square root over 9, 4 means what? 16, and 12 means what? 144. So we get the required result is 169. That means 13 is the required result. Distance of the point minus 1 minus 5 minus 10 from the point of intersection of the line and plane. Okay, understand everybody?
Yes, sir.
Yes, sir.
So this is the required result of the distance. Okay, now another example. 4. Find the equation of the line through the point 1, 2, 3 parallel to the line, given line x minus y plus twice z minus 5 equals to 0 equals to thrice x plus y plus z minus 6. So actually we are given, the given line is line x minus y plus 2yz minus 5 equals to 0 equals to thrice x plus y plus z minus 6. This is equation number 1. The direction ratios of 1 are given by what? X minus y plus twice z equals to 0 and thrice x plus y plus z equals to 0, given by this one. Okay, solving by cross multiplication, cross multiplication we get what? X divided by what will be? Minus 1 minus 2, right? And y divided by what will be? Y divided by 6 minus 1, and z divided by what will be? 1 plus 3. Okay, therefore we can write x divided by minus 3, y divided by what? 5, and z divided by 4. Therefore the direction ratios are what? Minus 3, 5, and what? 4. Now any line through 1, 2, 3 given point 1, 2, 3, what will be the line? Is x minus 1 divided by what? Minus 3. This is direction ratios are taking ABC. 1 minus 2 divided by B, z minus 3 divided by C. Okay, and this is equation number 2. Since from our given condition the parallel, the line is, the equation line is, the line 2 is parallel to what? Line 1. Therefore the direction ratios, therefore a divided by this minus 3. Okay, B divided by what will be? 5. B divided by 5, and C divided by what will be? 4. Suppose this is R, say, okay, say this equals to R. Therefore A equals to what will be? A equals to minus thrice R, B equals to 5R, and C equals to what? 4R. Now putting the value of ABC in equation 2. Of A, B, C in what? Equation 2. We get what actually? X minus 1 divided by what will be? Minus thrice R. Y minus 2 divided by what will be? 5R equals to Z minus 3 divided by what will be? 4R. So therefore R will be cancelled from all ratios. We get the required line is this. minus 3 equals to y minus 2 divided by 5 z minus 3 divided by 4. This is the result. This is the required straight line. Okay, now another example 5. We have to find the equation of the plane through the point 2 minus 1 0. 2 minus 1 0. This is invisible. 2 minus 1 0, and another point is 3 minus 4 5. Okay, and parallel to the line twice x equals to thrice y and equals to 4z. Okay, so the given line is actually what? Twice x equals to thrice y equals to 4z. So this can be written as a ratio. That means 3 4 to LCM what? 12. So dividing by 12 to all term, divided by 12. This can be written as what? X divided by 6 equals to y divided by 4 equals to z divided by 3. This is the equation number 1. So any plane through the point, any plane from the previous chapter, we must know the equation of plane through a point. Any plane through the point 2 minus 1 0. This is the given point. 2 minus 1 0 is what will be a into x minus 2 plus b into y plus 1 plus c into z minus 0 equals to what will be 0. This is equation number 2. Again, plane 2 passes through the point, another point, given point 3 minus 4 5. Okay, so we can write easily in place of x y z, x equals to 3, y equals to minus 4 and z equals to 5. That means a will be 3 minus 2 plus b into minus 4 plus 1 plus c into 5 minus 0 equals to what will be 0. So from this we can write a minus thrice b plus 5c equals to 0. This is equation number 3. Now eliminating, again the plane 2 is parallel to the line 1. Again the plane 2 is parallel to line 1. To what? To line 1. Okay, so if line 1 and this plane 2 is parallel, then we can write this is the directional ratios, 6 into a. So we get what? 6 into a, 4 into b plus 4 into b plus 3 into c equals to what will be 0. And this is equation number 4. Okay, now eliminating a b c from 2 3 and 4. That means from equation 2 and this is 3 and 4, just eliminating, we can form the determinant. The determinant like this. This is the x minus 2, a coefficient what? X minus 2, and here a coefficient what? B coefficient y plus 1 and z coefficient only z. Okay, So from the equation 3, a coefficient what? 1, and B coefficient -3, and C coefficient what? 5. From 4, a coefficient 6, B coefficient 4, and C coefficient will be 3. And this determinant will be 0. Okay, now just simplifying this determinant, we get the required equation of plane. Okay. Now from this, we can write like this: x minus 2 after this line, x minus 2 into what will be? -3 into 3 what? -9. Okay, -9 -20. Okay, and minus y plus 1 will be what? Minus y plus 1. 5 into 6 what? Minus 1 into 3. Then 3 minus 30. Okay, and that will be what? 4 plus 18 equals to 0. So from this, actually, we get minus 29x, 27y, 22z plus 85 equals to this 0. Minus 85 will be 0. And this is the required plus 27, 22z plus 85 equals to 0. And this is the required equation of plane. Okay, this is the required equation of the plane. Now another example 6. Find the equation of the line through the origin in the plane x minus 2i y minus 2i z equals to 0 and perpendicular to the line x by 3 equals to y by -2 equals to z by 6. So first of all, the given plane x minus 2i y minus 2i z equals to 0. And this is equation number 1. And the line what? X by 3 y divided by -2 equals to z divided by 6. This is equation number 2. Now through the origin, any line through origin, okay, through origin is x minus 0 divided by a, y minus 0 divided by b, and z minus 0 divided by c. This is the symmetric form of a line. So this can be written as what? X divided by a, y divided by b, and z divided by what? C. And this is equation number 3. Okay, equation number 3. Now the line 3 lies on the plane 1. Since the line 3 lies in plane 1. So lies in plane 1. This is why you can write the directional ratios a into coefficient of x. That means a into 1 minus coefficient of y what? -2 into this b and -2 into c equals to what will be? 0. And this is equation number 4. Again, since the line 3 is perpendicular to the line 2, this line also perpendicular, given perpendicular to line 2. Again, since the line 3 is perpendicular to equation 2. Okay, so in that case also 3 thrice a minus twice b 6c equals to what will be 0. This is equation number 5. From 4 and 5, from 5 and 4, we get what actually? Thrice a minus twice b 6c equals to 0, and other is a minus twice b minus twice c equals to 0. Just solving this, solving by cross multiplication. Solving by cross multiplication, what we get? A divided by what will be? Coefficient minus 2 what will be? Only 4, and 6 into minus 2 minus 12, minus what? Plus 12. B divided by what will be? 6 into 1, that means only 6 plus 6. C divided by what will be? 3 into 2 minus 6 plus 2. So from this we get what? A divided by what? 16, and B divided by 12, and C divided by what will be? Minus 4. So therefore this can be written as what? Divided by 4 on both sides. A divided by 4, B divided by 3, and C divided by minus 1. Suppose this equals to K. From this, A equals to what will be? 4K, B equals to what will be? Thrice K, and C equals to what will be? Minus K. Just putting the values of A, B, C in equation 3, we get the required line. Okay, just putting the values of A, B, C in equation 3. Putting value of A, B, C in 3, then we get the required line. Okay, therefore x divided by what will be? 4K. Y divided by what will be? Thrice K, and Z equals to what will be? Minus K. Therefore dividing and multiplying by K on both sides, on all sides, we get the required line. X by 4 equals to Y by 3 equals to Z divided by what? Minus 1. This is the required line through the origin in the plane x minus 2y minus 2z equals to 0, and perpendicular to the line, given line this. So very easy equation for you. Now the another important part of the straight line in three-dimensional geometry is the actually shortest distance. Okay, shortest distance, or SD. Okay, what will be the shortest distance? And the straight line which is perpendicular, the straight line which is perpendicular, perpendicular to each of their two non-intersecting line is called shortest distance. It's called the shortest distance, and the length of this line and the length of this line this line intercepted between the given line between the given line is called length of the shortest distance. Length of the shortest distance. So suppose there are two line in our saying. Suppose this is the L and this is the M line. Suppose this is the line and this is called the shortest distance. This is the SD. Okay, this line will be shortest distance if it satisfy this condition. Suppose B is another point here and D is the, suppose like this D. Okay, D is the another point and this is x1 y1 x1 y1 z1 and this is x2 y2 z2. Okay, so you must know that this is the perpendicular to each other. Okay, this means this is the shortest distance, not will be this. So LM is the actually shortest distance here. Okay, a problem about shortest distance. Example 7. Show that the length of shortest distance between the lines x plus 3 divided by minus 2 equals to y minus 6 divided by 3 equals to z minus 3 divided by 2. A semicolon x by 2 equals to y minus 6 by minus 2 equals to z divided by minus 1 is 3. We have to find the shortest distance is 3. Okay, and the line of the shortest distance cuts OZ. Now we are given the given lines are solution. The given lines are x plus 3 divided by minus 2 y minus 6 divided by z minus 3 divided by 2, and another one is x minus 0 divided by 2 equals to y minus 6 divided by minus 2 and z minus 0 divided by minus 1. This is equation number 1 and this is equation number 2. Okay, and minus 3 6 3 minus 3 6 3 minus 3 6 3 is a point on line 1. Okay, and 0 6 0 is a point on line 2. Okay, let L, M, and B direction cosines of the shortest distance line. Okay, between the lines 1 and 2. Okay, then we get, so we get immediately, this is the ratios minus 2 minus 2L and 3M plus thrice M and 2 twice N equals to what will be 0 from the first line. From the second line, twice L minus twice M minus n equals to what will be 0, and this is equation number 3, and this will be 4. So after solving this, we get the LMN. Okay, so solving it by cross multiplication, okay, cross multiplication, we get what? L divided by what will be minus 3 divided by plus 4, 2 to 4, minus minus will be plus, m divided by what will be 4 minus 2, and n divided by what will be 4 minus 6. So we get actually what? L divided by 1, m divided by 2, and divided by what will be minus 2. So this equals to can be written as L square plus m square plus n square divided by what will be root over 1 root over what will be 1 square 2 square plus 2 square. So this equals to actually we get 1 by 3. Okay, 1 by 3. Therefore L equals to what will be? L equals to 1 by 3, m equals to what will be 2 by 3, and n equals to minus 2 by 3. Now length of SD, therefore length of SD will be length of SD, that means shortest distance will be given by the formula L into x1 minus x2 plus m into y1 minus y2 plus n into z minus z1 minus z2. Okay, this is the formula for finding length of the shortest distance. X1 x2 means what? X1 x1 y1 z1 and x2 y2 z2. So just putting these values here, minus 3 0, we get 6 minus 6, m will be what? M will be 2 by 3, and n will be what? Minus 2 by 3, and z1 minus z2 means what? 3 minus 0, 3 minus 0. So the length will be given by what? This is the minus 3. Remember it, this is the length, never be negative. So only shortest distance will be what? 3. Proved. Okay, they proved. This is the proved result. Therefore the length of shortest distance between these lines is 3. Proved. Okay, now the second part, part 2, second part of this, that means we have to find the line of the shortest distance which cuts the OZ. That means the equation of the plane, the plane containing the line 1, containing the line 1 of shortest distance will be what? Line 1 from x plus 3, y minus 6, z minus 3. This is from line 1, only variable point. Minus 2, 3, 2, 1, 2, minus 2. And this plane, this is the equation of the plane. So from this we can write x plus 3 will be what? Minus 6, minus 4. Minus y minus 6, what will be? 4 minus 2, and plus z minus 3 will be what? Minus 4 minus 3 equals to 0. So after simplification, we get the equation of the plane containing the line 1 of the shortest distance will be given by 10x plus twice y plus 7z minus 3 equals to 0. Again, the equation of the plane containing the line 2 of shortest distance. So from line 2 we get x minus 0, y minus 6 and z minus 0. Okay, and 2 minus 2 minus 1, 1, 2 minus 2. This is the 0. So after simplifying this, we get the equation of the plane containing line 2 will be this: twice x plus y plus twice z plus 6 equals to 0 after this line. Therefore, the line of the SD, line of shortest distance, is what will be? From the first line we get 10x plus twice I plus 7z minus 3 equals to 0. This equals to what will be? Twice x plus y plus twice z plus 6. Okay, this is equation number what? What will be? 5 maybe. From our previous serial number of equation, this is the equation number what? 5. Let x equals to 0, x equals to 0. From equation 5 we get what? Actually putting z x equals to 0 here, we get twice y plus 7z minus 3 equals to 0, and another one what will be? Y plus twice z plus 6 equals to 0. So solving this by cross multiplication, okay, by cross multiplication we get what? Actually x divided by what will be? Sorry, y divided by y divided by 42 minus 42. This will be minus 42 y values minus 42 plus 6. This equals to z divided by what will be? Z divided by minus 3 plus 12 equals to 1 divided by what will be? 4 minus 7. Just by cross multiplication method. You must know from this. So from this we get y equals to what? Y equals to 12 and z equals to what will be? Minus 3. So after solving we get actually therefore the point x equals to 0 comma 12 comma minus 3. This is the point on what? On shortest distance, on the line of shortest distance. Hence x coordinate is 0 and y coordinate is not 0, and y coordinate is not 0 from this point. So shortest distance, the line of shortest distance is not cut OZ axis. Okay. So the coordinate of the point, so the point 0, 0, z is correct. But 0, 12 minus 3 is not correct. Okay. Z equals to minus 3. Okay. X coordinate is 0 and Y coordinate is not 0. This is why it's not in YZ OZ plane. Okay. This is the required result of second part. Okay, now another example about shortest distance. Example 8. Find the shortest distance between the lines x minus 1 by 2 equals to y minus 2 divided by 3 equals to z minus 3 divided by 4. And x minus 2 divided by 3 equals to y minus 3 divided by 4 equals to z minus 4 divided by 5. State whether the lines are coplanar or not. Okay, whether it is coplanar or not, we have to show the result. So we are the given lines are x minus 1 by 2 equals to y minus 2 divided by 3 equals to z minus 3 divided by 4. This is equation number 1, and another is x minus 2 divided by 3 y minus 3 divided by 4 equals to z minus 4 divided by 5. This is equation number 2. Let L, M, and be the direction cosines. Okay, directional cosines of the line of shortest distance. Okay, since the lines of shortest distance is perpendicular to the 1 and 2. Okay, 1 and 2. So we get twice L plus thrice M plus 4n equals to what will be 0, and this thrice L plus 4m plus 5n will be 0. Just solving this, now solving by cross multiplication method, we get what? L divided by m divided by n divided by. Okay, L divided by what will be? L divided by 15 minus 16, 12 divided by minus 10, and 8 minus 9. Okay, so this divided by L divided by what will be? Minus 1, and m divided by what? 2, and divided by what will be? Minus 1. So we can write easily what? L square plus m square plus n square divided by what will be? Square root over minus 1 square plus 2 square plus minus 1 square. That means this equals to 1. So we get easily what? Root over 6. That means therefore L equals to what will be? Minus 1 by root over 6. Okay, m equals to what will be? 2 divided by root over 6, and n equals to what will be? Minus 1 by root over 6. Again, 1, 2, 3 is a point on line 1, and another point is 2, 3, 4. 2, 3, 4 is on line what? 2. Okay. So this is the x1, y1, z1, and this is the x2, y2, z2. So length of the shortest distance, what will be? L into x1 minus x2 plus m into y1 minus y2 plus n into what will be? Z1 minus z2. Just putting these values, L equals to what? Minus 1 by root over 6. 1 minus 2 plus 2 by root over 6. 2 minus 3 plus minus 1 by root over 6. Z1 minus Z2 what? 3 minus 4. So from this we can write actually 1 by root over 6 minus 2 by root over 6, and this will be what? Minus minus plus 1 by root over 6. Therefore shortest distance is what? Actually 0. Since shortest distance is 0, since the shortest distance is 0, the two lines are, therefore the two lines are coplanar. Okay, coplanar, that means both lines are lies in the same plane. So the two lines are coplanar. Proved. This is the proved result. Okay, proved. Very easy example. The short if the value of shortest distance is 0, that means the two lines are in the same plane. That means the lines are coplanar. Okay, now another similar example. Example 9. Find the equation of the line of shortest distance and the length of the shortest distance between the lines. What? X minus 1 by 2 equals to y minus 2 by 3 equals to z minus 4 by 4, comma x minus 2 by 3 equals to y minus 4 by 4 equals to z minus 5 by 5. So the given lines are x minus these two, first line, and this is the second line. Similarly, let element be the direction cosines of the shortest distance. Since the line of shortest distance is perpendicular to the lines 1 and 2, so we get twice L. This 2, this 2, 3, 4 is the direction ratios. So multiplication, individual multiplication twice L, thrice M, 4n will be what? 0. Similarly, for the second line, thrice M, 4m, 5n will be what? 0. Now after solving by cross multiplication method, we get easily like this. L equals to what? L equals to minus 1 by 6, m equals to minus root over 6, and m equals to 2 by root over 6, and n equals to what? Minus 1 divided by root over 6. So 1 2 4 is a point on the line 1, and 2 4 5 2 4 5 is another point on line 2. So the shortest length of the shortest distance will be what actually? 1 minus 2 and 2 minus 4. Okay, 2 minus 4 and 4 minus 5. Okay, 4 minus 5. So we get actually what? 1 by root over 6, and this will be minus 4 by root over 6 plus 1 by root over 6. So we get what actually? Minus 2 divided by minus 2 divided by root over 6. This is the length of the shortest distance, 2 divided by root over 6. Now the equation of the plane containing the line 1. Okay, after this line, Okay, this is the actually length of the shortest distance. Now after this line, we can write after this line the equation of the plane containing line 1. Line 1 means this one. Okay, 1, and the line of shortest distance is given by from the line x minus 1, y minus 2, z minus 4, and 2 3 4, 2 2 3. This is the 2 3 4. Okay, 3 4, and minus 1 2 minus 1, minus 1 2 minus 1, minus 1 2 minus 1 means what? uh, this was minus 1 and this was 2 and this was minus 1. Okay, direction cosines, this will be 0. So x minus 1 into what will be? Minus 3 minus 8, minus y minus 2 into what will be? Minus 2 plus 4. Okay, z minus 4, what will be? 4 plus 3. This equals to what will be? 0. So after simplifying, we get from here, what can we get? Actually 11x plus twice y minus 7z plus 13 equals to 0. And again the equation of the plane containing line 2. Similar example we have done in our previous in your earlier of these classes. Similar example we have done an example. So and the line of shortest distance will be what? For the second line, x minus 2, y minus 4, z minus 5, and direction ratio is 3 4 5, 3 4 5, and minus 1 2 minus 1. This will be what? Actually 0. So from this we get another equation. So after this line, just we can write x minus 2 minus 4 minus 10 minus y minus 4 into what will be? 4 minus 3 plus 5, minus 3 plus 5 plus z minus 5, 6 plus 4 equals to what? 0. So after this line, we can find minus 14. What? Minus 14x plus 28, right? Sorry, minus 14. Then minus here will be only 2 minus twice y minus minus plus 8. Okay, plus 10z minus 50 equals to 0. So after this line, we can write what? So minus 14x minus twice y plus 10z, what will be? Minus 50 plus 28, what? And this 88 what? 36. So we get only 14. Okay, minus 14 equals to 0. And dividing by minus 2 on both sides, taking minus 2 common, we get what? 7x plus y minus 5z plus 7 equals to 0. So therefore we get only y minus 5z plus 7 equals to 0. Hence the equation of shortest distance is what will be 11x twice y minus 7z plus 13 equals to 0 equals to what will be this one plus y plus 5z plus 7. This is the required equation of the line of shortest distance. Okay, same example we have done in our previous. That means example maybe example 7. Okay, example 7 we have done this in example 7. Okay, now final example, final problem of this chapter. That means last one, example 10. Example 10, find the length and equation of the shortest distance, okay, between the lines thrice x minus 9y plus 5z equals to 0 equals to x plus y minus z and 6x plus 8y plus thrice z minus 13 equals to 0. This equals to x plus twice y plus z minus 3. That means we have to find the length as well as the equation of the shortest distance. The given solution, the given straight line are thrice x minus 9y plus 5z equals to 0 equals to x plus y minus z. This is equation number 1. And second one is 6x plus 8y plus thrice z minus 13 equals to 0 equals to x plus twice y plus z minus 3. This is equation number 2. So the direction ratios, therefore the direction ratios of the line of the equation 1 has the form 3 minus 9 5 3 minus 9 and 1 1 minus 1 1 1. That is, we can write this is a difference. Okay, 9 minus 5, 9 minus 5, 5 plus 3, 3 plus 9. That is 4, 8, 12. That means what? 1, 2, 3. This is the direction cosines from equation 2. Sorry, from equation 1. Then that means just solving this and this, we get this one. Okay. Let x equals to 0. Then from equation 1, we get what? Minus 9y plus 5z equals to 0, and y minus z equals to what will be? 0. So after solving this, what we get? Z equals to 0 and y equals to what will be? 0. Therefore, the point x was what? 0. The point P 0, 0, 0 on the line 1. Okay. Therefore, the standard form of 1, what will be? Of 1 will be what? X minus 0 divided by direction ratios 1, y minus 0 divided by y minus 0 divided by 2, z minus 0 divided by 3. And this is equation number 3. Okay. Again, for the line 2, direction ratios will be what? Direction ratios will be 6, 8, 3, 6, 8, 3, another 6, 8. Then we get 1, 2, 1, 1, 2, 1, again 1, 2. Okay. That is, we get actually 8 minus 6, 8 minus 6. Another will be what? 3 minus 6, 3 minus 6, and 12 minus 8. 12 minus 8. That means we get what? 2 minus 3, 4. Okay, 2 minus 3, 4. Again, let x equals 0 in equation number 2. Then from equation 2, we get what? 8y plus 3z equals to 13, and twice y plus z equals to 3. Now solving this, y equals to what? Just solving, multiplying 3 by this, then subtract, z will be cut. So 6y, 8y minus 6y what? Only y. So y equals to, we get only 2, and z equals to what will be? Minus 1. Okay, solving this we get. So after this line, actually we get what? After this line, we get the same, the standard form, the point x was what? 0 and y 2 minus 1 is a point on line what? 2. Then standard form of 2 will be what? X minus 0 divided by what was? 2, y minus 0, sorry, y minus 2 divided by direction ratios what? Minus 3 equals to z minus 1. That means z plus 1 divided by what will be direction ratios what? 4. We can use this process. We can also use cross multiplication process, okay, to get these direction ratios. I have solved in earlier examples. So you can use this method also. You can use the cross multiplication method to find the direction ratios. So this is the equation number 4. Let LMN and be direction cosines, okay, direction cosines of shortest distance, okay, between two lines of what? 3 and 4. So if LMN be the direction cosines, then we can write easily L into of 3. This is the equation number 3. You must know this is the equation number 3. Okay. So L into 1, L plus M into 2, twice M plus thrice N equals to what will be? 0. And twice L for the from the equation number 4. Twice L plus, sorry, minus thrice M plus 4N equals to 0. Now solving this by cross multiplication, method, what we get? L divided by what will be? 8 plus 9. Okay. M divided by what will be? M divided by 3 to 6 minus 4. And N will be what? Minus 3 minus 4. Okay. So this equals to square root over L square plus M square plus N square divided by what will be? 8 and 9 what? No. First of all, you have to simplify first. So we can write what? L by 17 and M divided by what? M divided by minus 2 equals to N divided by minus 7. So from this one, L by 17 equals to M by minus 2, N by minus 7. This equals to square root over L square plus M square plus N square divided by what will be? Root over 17 square plus 2 square plus minus 7 square. That means we get what? 1 divided by what will be? Root over 342 maybe. You can calculate. So therefore, L equals to what will be? 17 divided by root over 342. M equals to what? Minus 2 divided by root over 342. And N equals to what will be? Minus 7 divided by root over 342. Now the length of shortest distance. What was the formula? L into x1 minus x2 plus m into y1 minus y2 plus n into z1 minus z2. So L equals to what? Actually 17. Okay. 17 divided by root over 342 and x1 and x2 what? What's the point? This is the point. This is the point in line 2 and point line 1. Difference is 0, 0. Okay. 0 minus 0 plus 2 divided by 342. This will be 2. Remember it. There is a mistake. So 2 divided by y1 minus y2 what? 0 minus 2 and plus minus 7 divided by root over 342 z1 minus z2 what? 0 minus minus 1, that means 0 plus 1. So we get easily this is the 0 and this all minus 4 by this and minus 7 by this. So we get minus 4 minus 7, what will be? Minus 11. Minus 11 by root over 342. So this is the actually required result because this will be absolute value. So we get only distance can never be negative. This is why 342. Shortest distance is also a distance. So it will be the positive one. 11 by root over 342 is the required shortest distance. Okay, now the equation of the plane plane containing the line. The line 3 and the line of SD is what will be from the line 1. You must know x minus 0, y minus 0 and z minus what will be 0. And direction ratios what? 1, 2, 3 from the line 1. Sorry, line 3 from the line 3. Remember it. 17 and this is the 17. This is 2 and this is what? Minus 7. Okay. This is the from the direction cosines equals to 0. We can easily solve this by what? First of all, x into what will be? Minus 7, minus 14, minus 6. Okay. Minus y, what will be? Minus y. What will be? Minus y. Minus 7, minus 51. Plus z, what will be? 2 minus 34. This equals to what? 0. Okay. So we get easily here from here minus 20x plus what will be 20 plus 58y minus 32z equals to 0. So by dividing by 2 on both sides, minus 2 on both sides, minus 29y plus 16z equals to 0. Similarly, the equation of the plane again the equation of the plane containing the line, what will be? Line 4 and the line of shortest distance will be what? From line 4 what? X minus 0, y minus 2 and z plus 1. Direction ratios what were? What was 2 minus 3, 4. And direction cosines 17, 2 minus 7. This same. Third row is same. Minus 2, minus 7. This will be plus 2. So this equals to 0. That means solving this, we get what? X into what will be 21 minus 8 minus y minus 2. Y minus 2 what will be? Minus 14 minus 68 plus z plus 1 into what will be 4 plus 51. This equals to what? 0. So from this line, we get 13x plus 82y plus 55z equals to what will be? Plus 55 equals to 0. Now from these two, we get our required. Therefore, the equation of the line of shortest distance is what will be? Just these two line, minus plus 10x minus 29y plus 16z equals to 0. This equals to what will be? 13x plus 82y plus 55z plus here 55z, there plus 10 minus 109. Remember it, there is a mistake, and this will be minus 109. This is the required equation of the line of shortest distance. Okay, thanks to everybody. Bye for today. And best wishes for you. Thank you.